Welcome to another episode of Constructive Conversations. It's a sunny day in Trinidad and Tobago, and I am here on site, actually on a site with a friend and engineer, Brent Pascall. Welcome. Thank you so much, Brent, for being here.
Hi, Lisa. Thank you as well.
I know the sun is a little hot.
A little bit.
But I just wanted to really have this conversation with you as an engineer
Okay.
to just shed some light on what you do, what value you bring, how important an engineer is on a project. So tell us, what does the field of engineering entail? And I've heard of structural engineers, civil engineers. Clarify that for us. What's the difference between these fields?
Okay, Lisa. So nice to be out here in the sun with you. On a lovely day.
Yes.
So engineering, pretty much, the definition is the application of science to the environment,
Okay.
right? And there are various types of engineering. There is mechanical, electrical, civil. There is IT. So there are various types of engineering. I'm a civil structural engineer.
Civil structural engineer.
Correct. So civil being the broad umbrella,
Mm-hmm.
and under civil we have structural, environmental.
Okay.
We have water resources. We have transportation. So there are various subs under the civil.
Okay.
So I am a civil structural, meaning I practice the broad, most of the subs under the civil,
Okay.
but specify in structural.
And structural engineering entails what exactly?
That deals with any skeleton to any infrastructure. So meaning columns, beams, slabs, anything,
Okay.
the skeleton of any beautiful design that an architect would do. Yeah?
Okay. All right. And just because I particularly love bridges and the design of bridges, etc. Would that fall under your
Yes.
purview? That structural.
Yes.
Okay. All right. How do you become an engineer in Trinidad and Tobago?
Okay, so there is qualification and there's certification. Qualification meaning you went to accredited university and you have gone through the allotted number of years of study
Okay.
to be qualified as an engineer. So you have a BSc, then you go into a master's. Certification, however, is the apprenticeship that you have to go through, usually 4 to 5 years,
Okay.
depending on the country that you're in, under a chartered or registered engineer.
Okay.
And then you apply to whatever the board is. So in Trinidad and Tobago, it's the Board of Engineers of Trinidad and Tobago. So you apply to the Board of Engineers, you submit your, usually it's your experience for the past 5 years or whenever you apply, whatever
Okay.
your experience would have been up to then since you have left school.
Okay.
They would go through the assessment and deem whether you are certified based on your experience, or they would make recommendations of what you have to acquire before they certify you.
Okay.
And that is where we get into registered engineers of Trinidad and Tobago.
Okay.
So once you're certified by the Board of Engineers of Trinidad and Tobago, then you are a registered engineer.
Okay. Is there like a written exam or anything of the sort? Interview?
So yes, for structural, there is, you actually have to do both an interview and you have to provide a full calculation document on, well, design,
Okay.
both the calculations and the drawings
Okay.
of a design.
Wow. Okay. Yeah, that's a lot.
There is also the Institution of Structural Engineers, which is an English, well, the largest institution of structural engineers well, in the world.
Yes.
And that's where you get into chartered. So you practice in various countries, that kind of
Okay.
thing. And that one, both depending on the tier that you're on, you either do an interview for the lower tiers, whether technician, technician or graduate. And for chartered, you actually do like a 7 or 8 hour exam.
Okay.
And yeah, then you're certified now as a chartered engineer.
Chartered engineer.
Yeah.
I know in this design field, architects, engineers, we work together, and we work alongside other professionals. But tell us, what is the benefit of having an engineer as yourself on a project?
Okay, so firstly, I'll start with what the engineers do,
Do right.
and that will lead to give benefits. So please see it there. So essentially, we start from the conceptual design. So the architect produces their designs,
Drawings.
whether it's final or probably at intermediary.
Preliminary
Right.
stage, okay.
We get in there and start to do some concepts, saying,
Okay.
well, this is where we would like to put columns.
Okay.
This might be where a beam would be. And that affects the architect's layout. So if there's a column where you have a sink,
Right.
the architect may not want that there.
Right.
So now the architect says, okay, can this be shifted?
Right.
So we are the ones that come in and we say, well, for the building to work as the architect has designed, we would need a column. But this is the location we would want the column. And there's usually a back and forth.
Yes.
So there are various stages,
Okay.
conceptual, preliminary, estimating,
Okay.
tender, construction.
Okay.
Yeah, so there are various stages, and we produce the designs up to tender or estimating, where the client is now able to get what the cost of this, both structural and architectural, the walls, the columns, the windows, what that would cost.
Okay.
At that stage of the project.
Okay.
Following that, we get into the construction drawings, which usually is not a large variation from tender stage. And this is where the client now has construction drawings to engage a contractor from the tender stage.
Okay.
Right? So this is actually the all our legal documents, but the construction drawing is actually what is going to be used to build. And this is where the hard legal part of it gets into play.
Okay.
So we do the designs, finding where your columns are,
Sizing.
spans, cantilevers, removing columns, as the architect
Yeah.
sometimes like.
Yeah, because sometimes we design and we have to have that conversation about what should go
So it's
where.
usually a back and forth, a very lovely relationship
No
between
pressure.
architects.
No pressure.
So we work together with the architect in producing this design to make the building work.
Okay.
Yeah, as it is, walls alone usually are not sufficient to withstand earthquakes or wind load or even natural self-weight.
So you take into consideration those natural elements of wind and earthquakes.
Drainage, flooding.
Okay.
Drainage. Flooding is really a site selection issue. If you build in a floodplain, then you're going to get flooding, right? So yes, we actually consider the seismic element, which is earthquakes, and wind, primarily in our design. Self-weight is usually always considered in our design.
And when you say self-weight, you're talking about
the materials you use to build.
Right.
Those have a weight. Once you start stacking them up, once you start putting up blocks for a wall, that now has
a certain amount.
Correct, on your slab.
And final, the furniture, and would you consider that kind of weight in the end?
Correct. So that is used to design both the slab and the beams.
Okay.
So based on the building class, residential, commercial, schools, hospitals, financial buildings, government buildings. There are different classifications based on code of practice, whether it's American code, Euro code, depending on the country that you're in, Canada, that kind of thing. Yeah. So all of that ties into producing this lovely product.
Yes.
Working together with the architect, sizing the beams, locating them, and very economical, as well as with some safety factor in it. So we don't design just for what the client requires. There's always a safety factor, plus most of the times, of a greater load. So if you need
in future,
correct,
if there is expansion or anything of that sort, you would have already catered for that.
Yes. Okay. So a client may do a building, they may have 3 bedrooms, later on they choose to use a bedroom as a gym and they bring weight, a
Yes.
heavier loaded equipment. So the safety factors usually take into account for some of those things. May not be all drastic
Yeah.
changes, definitely no. So that's why we have these classes of designs.
In terms of a renovation, you would still need to be on such a project like that, like a renovation, because I know some persons might have the idea, well, okay, I'm just adding on a room upstairs or downstairs, I'm adding a carport. Would you play a part in that
Yes, usually,
renovation?
yes, usually we would come in as the structural engineers and we would determine whether the existing columns, if they're existing columns or the slab, can take what your renovation is. So usually, Trinidad and Tobago, we like to put on an extra room in the
Right.
back, you know, and usually it's not tied to the building. So it's not carried by the existing building's foundation. That has to have its independent foundation.
Okay.
For cases where you build a second story, usually if it's the load-bearing wall system, apart from columns and beams,
Okay.
there's also load-bearing walls, which are pretty much reinforced concrete walls
Okay.
with steel concrete loaded, and those carry the weight of the building.
Okay.
So for those type of renovations, the walls are checked to see if they could carry the new load.
Okay.
Other than that, we do new reinforced concrete column and beam system framing.
So the benefit of really having you on a project is to ensure, I hear safety, you're talking about making checks for earthquake and wind, etc. And you do whatever necessary calculations to ensure beams and structural walls and columns are all sized correctly.
Right.
And somebody without that training, without your training, cannot or should not attempt.
We do not recommend it. We don't want to discredit what we call contractors with sufficient experience over the time working along with engineers and architects.
Yeah.
But it's not recommended for the layman to attempt it, especially where it becomes more complex. You have cantilevers,
Yes.
you have large spans.
Yes.
You want to move a column, you want to make an opening in a load-bearing wall.
Yes.
Those kind of things.
Yeah. So it's always better to work hand in hand with a contractor, an engineer, contractor, architect, engineer, contractor. The
Highly
team.
recommended. Correct.
Yes.
Highly recommended.
The team is always the better way moving forward.
Yes.
I agree.
Our services don't stop at the construction stage of the design.
Okay.
We actually provide inspections during the construction period, and that is to ensure that the contractor is doing what is in the contract documents, meaning the before construction drawings.
Okay.
As well as just verifying that the client is getting what they paid for.
Yeah.
So we put 1/2-inch bars in again, 3/8 bars in your
so
block
you
wall.
come on a site like this and you walk around and check.
Yeah, so on a construction site, there are various stages where we come in, foundation inspections. Well, firstly, we come to the site and ensure that the contractor has his for-construction drawings. That is the only drawing that the contractor should be using to build.
Only drawings.
Correct. Only drawings.
Only drawings.
Should be the for-construction drawings. Yeah, nice. So usually we ensure that is what sets the pace on the site. Ensure that they are on site and the contractor is using that to settle the building based on town country approvals, regional corporation approvals, that kind of thing. And we go through various stages. So foundations, we would have come to the site, ensure that the foundation trenches were cut to the correct width based on the for construction drawings. The material being used or the material being delivered to the site is what was specified in our drawings.
Oh, okay.
When any reinforcement, the engineer should check it before a concrete pour.
Oh, okay.
When the concrete is on site, we need to get the mill certificates to ensure that the concrete strength is what was specified in the concrete notes and the drawings. Moving forward, we go to the slab inspection, wall inspection, column inspection, beam inspection.
Wow.
block inspection again, roof inspection,
Yes.
connections, details.
Yes.
So yeah,
So you participate in this exercise throughout the entire
correct. So
duration.
yes, it's one thing having a proper set of 4 construction drawings, but your building doesn't conform to the 4 construction drawings. Who is liable for that at that point?
So Brent, you're doing site visits. You're coming, you're checking foundations and slabs and columns, and you're doing all the calculations even before the stuff that we don't see, the client doesn't see. It brings me to the question of how much do engineers really cost? Like, I know we're living in a time where we have to watch every dime, and some persons are worried that, you know, they spend money for a professional, but it really isn't necessary.
Right.
But we just established that you really do bring value, and it's beneficial to have you on a project. So tell us, how much do engineers cost?
These are the putting me on the spot, but I would speak to it in the sense of there are various ways that professionals charge. One would be a percentage of the construction cost. So previously, speaking about the tender drawings or the estimate drawings, at that stage you have an idea of what a project would be, right? What the cost of a project would be.
Okay.
Of your particular project, I should say,
Okay.
right? Would be. So we use a percentage of that cost, and it depends on the class of building. So residential, commercial, hospital,
Okay.
government buildings, schools, that kind of thing.
Alright.
That's one way, a percentage of the construction cost of the project. The second way will be lump sums. So based on man-hour build-up, how much time you would spend on a project, you actually charge the time that it would that would take you.
Okay.
Correct. Another way would be square foot. So we charge a fee based on the square foot of your building. The larger your building, your cost going up, right?
Right.
But the percentage fees that we actually charge, or the man-hour fees, or the square footage fees that we charge based on a project is the least cost of the entire project. Meaning, at the estimate stage, when you actually get what your project costs, they split it up into elements like foundation, block walls, windows, roof, beams, columns, steel. And if you check what the professional fees are, either of the professionals, the architect, the structural engineer, the MEP engineer, those are actually the least costs in your entire project.
Wow.
So I wouldn't sacrifice a headache-free
Yes.
project for a few percentage fees.
Yeah.
Yeah.
So give us some advice. Give advice to maybe like the homeowner, somebody who's doing a renovation, or a developer, somebody. Give us some advice to when it comes to starting a project.
My long and short advice would be to engage the professionals. We see a lot of stall projects resulting from lack of engaging the professionals. So you start a project not having the cost in mind. You start a project not having the design fully thought out.
Right.
The structure not fully designed. And you have a project that is stalled with, well, you also have lack of approvals.
Yeah, which is another issue.
Correct. So you end up with a lot of stalled projects for whatever reason, various reasons. Most of them stemming from lack of engaging the professional, or having advice from the professionals. You can work with them. Yes, the fee might be a concern.
Yes.
But I'm sure you could work with the professional. This is your budget. This is what you want to achieve. Engage them and at least get the advice, get their recommendation. If you can't start it now, then you have a way forward, or they give you an idea of what you have to do to get this moving off the ground and finished and living.
Ready.
Enjoying your new structure. So long and short would be engage the professional.
Don't let that stall project be your project. Thanks, Brent, for giving us that good advice. Stay tuned for more episodes of Constructive Conversations.